morning. Let's just remind ourselves. Remember last year when we were doing solving a square root equation like this one? Whoops. And I told you you take the square root of both sides, and some of you already said v equals 4, but you missed it. The point of why I'm doing this, v doesn't equal 4. V equals positive or negative 4. Because when you take the square root of both sides, you have to remember that negative 4 squared equals 16 and positive 4 squared equals 16. So here it says to write your answers separated by commas. Okay, well, suppose we had one that wasn't a perfect square. Well, so here you have x squared equals 28. So you're going to take the square root of both sides. So x equals positive or negative. Let's just simplify this while we're going. It has a 4 as a factor. So if we take that out, 2 and 4 times 5, 6, 7. 4 times 7. So this would be 2 square root 7. So here our answers would be 2 square root 7 and negative 2 square root 7. It's the positive or the negative answer. And I'm showing you this because, we get to this place where we have this quadratic formula. This isn't just a song we sing. Negative b plus or minus the square root of. See here, that's just, that's just what it is, because we take the positive or the negative of this whole thing will work. B squared minus 4ac. Okay, so all over 2a. Okay, so we're going to be using this in a minute in a different way than you've seen before. But first let's look at just some qualities here of a parabola. So here's a parabola. It opens upwards. So first question says, does it open up or down? It's going to ask us for its vertex, its x-intercepts, its y-intercept. So find the equation of the axis of symmetry. So symmetry, in other words, the line of reflection, it would be this x equals 3 line, because it unfolds about that line right here. Okay, so, and the vertex is going to be the point 3, negative 1. So the equation of the line of symmetry, axis of symmetry, x equals 3. Okay, find the intercepts. X-intercepts at 2 and 4. 2, 4. Y-intercept, was that 0, 8? It is 0, 8. I'm wondering if it just lets you get away with putting in the numbers. Let's see together. I might, because here it already knows it wants a point. It opened up the parentheses for me. So yeah, that's all it wanted. So it didn't want the whole point. Okay, so here now we get to the meat of today's lesson. Find all the complex solutions of this. Now, if I went back to this one here, and take a look real quick. These are, oops, where'd it go? Okay, these are called real roots. They're real roots because it's where the parabola crosses the x-axis. Okay, now if this parabola was down a few notches, down here, it wouldn't have any real roots because there's no intersection of this parabola with the x-axis. Or if it was up here, no real roots because it's not crossing this x-axis anywhere. So in that situation, we have to have what we call complex roots. Complex roots are made up of imaginary numbers. Okay, so let's say you had the square root of -16. It doesn't exist. So what we do is we use this principle, -1 times 16. So then we can factor it, and I'm just showing you all the steps that allow this to be this. And there's just one rule. This doesn't exist. So what we do is we invent the imaginary number I to be a placeholder for this. A placeholder. So it's going to hold its place. It's like a variable. You put a variable in to hold something's place. You do the math, and then you can put your number in and see what you get out, okay? This is a little different, but we make this as a placeholder. So we can do the math on something that is undefined by having this placeholder. So we factor that out, and what we get is I4. Try not to write the I at the end, because you could get it mixed up and the operations get confused, and it looks like a variable when you do that, but it actually has a value. It has a value that is imaginary. Okay, so let's go back to that question now. So we're going to use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so if we were to put these numbers, a, b, c, into our quadratic formula, we would get, let's see, -5 plus or minus the square root of 25 minus 4 times a times b all over 2 times a. 2 times a. 2a. b squared. 4 times a times c. Okay? And then if we simplify this, we're going to get 5 plus or minus the square root, and this becomes 25 minus 96, or -71, all over 12. Now, you look at that and you think it's ugly, you think I got some ugly math to do. Not true. We're done, essentially, because it doesn't simplify. 5/12 doesn't reduce. 71 doesn't, nothing factors out of that. So only thing we can factor out of that is I. And so we do 5 plus or minus I. That's how you just take the negative sign out, the square root of -1 times this, take the I out. And so what we enter is 5 plus I root 71 over 12, comma, 5 minus I root 71 over 12. Okay? So you're going to do that a few times today. So if you think you got it, try one, pause here in case you didn't have it, because I'm going to do another one for you right here. So x equals -b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Okay, so I've got -1 plus or minus the square root of, let's see, 4 times 2 is 8, times 6 is 48. 1 minus 48 is -47 over 4. Now, we're done. Nothing simplifies again. So we're going to put in -1 plus I root 47. Bring that all into the numerator. 4, comma. I wonder if it lets me copy and paste. That would be too easy. Copy. Nope. So, -1 minus square root I 47 I square root I square root over 4. Okay, so it's really not as hard as you might want it to be, but anyway, good luck with that, and check back for tomorrow's lesson. There's a couple of new things you should know in there. Make it a lot easier to see it once. Even easier if you're online asking questions in the morning. All right, bye.